Welcome back to Nature of Code in Rust and GGEZ. We're moving on to exercise 2.2. We're going to rewrite the apply force method using the static method div instead of get. Well, this is referencing an earlier examples where we're basically now starting to use mass in our apply force to sort of change how the forces is applied to the mover object. So to begin with, we're going to need to add a mass to our mover. The first thing we're going to do is probably just like give everything like a random mass. Let's have it passed in when it's given to us. So first of all, we're going to track mass. It's going to be an F32, and let's have mass come in here, which is an F32. And so that way we can just store it right in here. That's going to break our main library, where we have to tell it when we give it a mover that your mass is, we're just going to give it an example of 10 for right now, but it can be anything we want. And later on, I'm assuming the book is going to have us create a whole bunch of mover objects, each with a different mass. Back to our mover. We're going to come down to apply force. And the idea is we're going to take this force and we're going to divide it by the mass first before we're able to apply the force to the acceleration. Okay, so what the lesson here is we need to get a copy of the vector force. So let our force, like it needs to be a copy of this force. It can't be the exact force coming in. Now, our vector 2's implement copy, meaning that it will be a different version of this force if we want it to be. So if we wanted to say, let maybe like a other force, maybe like force divided by mass. What would this be? Like, it's not necessarily a scaled force. This could be, we could just shadow the force. So shadow the force, we're going to say this force. Now, if I do divide scalar, that's going to update the force itself. Now, the big thing here is that this isn't mutable. So this is not gonna work for us. But we can copy the force. So let force equals to the force. We're gonna make immutable here. And then we can do force dot divide scalar by self dot mass. And then it's going to update. If we run this, if we remember what it sort of looked like last time, it should be a little bit slower as the balloon rises up. But besides that, there's not really much that's happening. In fact, we notice that it just sticks to the surface because now the mass is too heavy for the small amount of downward force to have it bounce off the surface. But that's neither here nor there, because that is exercise 2.2, which is adding in this, this idea of mass and making sure that we're not manipulating this force in the case that it's going to be applied to many different movers all at the same time. So with that, I will see you in the next video. Thanks. Bye.